I just picked this calculator up off my pile of calculators. It's not hugely interesting. It's a Casio FX100c, which I suppose is a bit unusual. It's got base N, which is nice if you're doing stuff in hexadecimal. It's also got random numbers and so on. But it had a battery in it, as you can see. It was powered on, so I decided to take the battery out, because I don't want to leave batteries in calculators. Now unfortunately this calculator is not working. The display is knackered, which is a bit of a shame. But when I took it apart, take the back off as usual, and you're presented with one of these film calculators with battery at the top, display, and all of the circuitry of the calculator, well, sort of, is on this film here. There's buttons on the underside. Now what's interesting is these buttons, they seem to be in, the whole film is actually carbon, so there's carbon traces all over the film, apart from a capacitor here. Now the capacitor isn't soldered onto the film, it's actually just pressed against these two pads here, and so are the battery terminals here and here, which means you can't actually power this up without having the back on, because the battery connections aren't connected. And the flexi or film PCB goes all the way up and straight onto the LCD, so everything's on just this one bit of film. There's no PCB at all. The main IC here must do everything, because there's only one IC and a capacitor, and that's it. If I pull the display out, you can see that, it's a bit tricky. Let's get a screwdriver to do that. The display's knackered anyway. If you pull that out and I flip that over, you can see that the chip is actually embedded in epoxy, and the wires are here. I think they're actually accessible, which is a bit odd, but the only way of turning it on is to press these two contacts together, which isn't working at the moment. And the other thing that's quite interesting is that the carbon contacts for the keys, these are carbon traces, so this is the equivalent of the PCB with the sort of contact pattern there. The carbon traces are on the case, so these circles here are actually carbon. And what this means is the only real way of powering this up and using it is if you've got it put together, because the keys are actually on the back of the case. So it makes it really difficult to work on when you've got the case open. You've really just got to get some sort of key and press it down manually on here. That would probably work. But then you've got to hold the battery connections on here, and presumably that capacitor. I suppose I could solder that on, and I could solder these on here, but I'm not sure you can solder to this sort of this sort of film, because they're metallized on the back, so maybe you can solder to the back, but on the other side they're carbon, which isn't going to be able to be soldered to, I don't think. I mean, it's a bit like some other film calculators, but it just seems to be put together a lot better, and it feels a lot better when you use it than some of the Texas Instruments ones. I took one apart in another video. But how you work on this, how you actually power it up and work on it on the bench, there must be some special jigs to spring load the capacitor, or maybe you just sacrifice the flexi and solder to it. Maybe that's why there's a bit of metallized stuff on the back here. But yeah, amazing. The display isn't screwed in, that's held in with a squishy pad there, and the battery connections are just these bent bits of metal that goes down to these spring connections here and here. It's quite remarkable. I mean, there's a lot of thought gone into this. For some reason, I don't know why, this is actually curved at the back. I don't know if the keys, is it curved there? Yeah, maybe slightly, but I don't know why they've done that. There's actually a curve here, but not here, for the contacts for the keys. Also, where the capacitor goes, they've actually cut out, and there's a recess there for the capacitor in the back case. So obviously they're keeping this as thin as possible, and they've gone to the extent of putting the recess there. Maybe it's for the IC. Maybe this curved part here is for the IC, although the keys are slightly curved there. Yeah, remarkable. So I can't get the display working. It's a heat seal connection and they're terrible. So I've taken the flexi PCB out, the membrane PCB, and it turns out it's double-sided. There's tracks on this side and there's tracks on this side. And the vias seem to be some form of 3 punctured pins that run through from one side to the other. I don't know how that works exactly. Whether they puncture it and then draw the traces and the carbon goes through the holes, or they puncture it afterwards. But you can see there the back of the die, which is just encased in looks like epoxy with some sort of insulating tape on top. So that's really interesting. So this form of making a PCB, you could probably do that on a 3D printer, some form of CNC machine. So you put the film in, paint the traces, puncture and paint the traces, turn it over, paint the other traces, and you've got a PCB. The main problem is how do you get components on there. I'm not sure how they've done that. I'll stick it under the microscope and see if we can see how the traces have been attached to the die that is on there. But the capacitor, which is here, which as it turns out is glued into the case, the legs of that just goes here and here, and this is the battery connections here and here, which is carbon. So if you could get components onto something like that, you could make a PCB just using carbon and film. Or I suppose you could use some sort of hard substrate. Obviously they're doing it for cost here. So on the microscope, carbon tracks come in there and then they go into the epoxy, and then I think it must be some sort of pressed connection because they're the silver tracks, some metal track that's going off to the die, and that's the junction there. So I can only assume the film is pressed onto that, and then the whole thing's encapsulated, and then that runs off and they gradually collect up and end up running into the die, which I think is somewhere here. And this is a via, so we've got a track on the top there, big black track, which is running up to this via here, and there's the 3, well, they look like puncture marks, and that faint track there is the track running on the other side of the film. So it's difficult to see what's going on there, but it definitely looks like 3 puncture marks, so they've punctured from one side through to the other. But whether that's done before or after the carbon goes on, I'm not sure. Very interesting.